Okay, good evening to all. Today our class is angle transmitter logic and faults. Moving on. What is angle transmitter? In conventional logo, we'll name it as master controller. But in three-phase logo, we'll name it as angle transmitter. Both are same. Master controller, actually, it is the controlling master of the logo. It is the main interface between driver and the loco. So here are the parts. This is the top view and this is the bottom view of this angle transmitter. Here two knobs are there. One is direction selector switch and the other one is forward this traction lever switch. Here we have three positions: reverse, zero, forward. And here the throttle lever which have normally it will be in the zero position. Then in the up direction we have 1/3, 2/3 and T maximum, which we will call as traction region. And in the down direction we have 1/3, 2/3 and B maximum. Okay. Here at the bottom view we can see here one 13-pin circular connector which is having a supply of 110 volt DC. Here we have a 9-pin sub-D connector which is connected to the VCU which is having 24 volt DC. Here this is the bottom view of this direction selector switch. Here we have a switch with 4 auxiliary switches, 2 for the forward direction and 2 for the reverse direction. We have one redundancy. Here this lever, this is a drum which is connected to the encoder shaft. Here we can say it is a encoder shaft. This is connected with the spur gear. The spur gear transmits the movement of this traction lever to the encoder shaft. Encoder shaft we are having 4 auxiliary switches. One is for zero position. When all the interlocks are in open condition, VC will recognize it is in the zero position. There is no tractive effort or braking effort. When the first interlock is closed by giving a movement of 15 degrees to the encoder shaft, by giving this throttle lever, this encoder shaft will move for a degree of 15 degree. For that 15 degree, either this or this interlock will be closed. If we are moving in the up direction, first interlock will be closed. And if we are moving in the down direction, second interlock will be closed. Meantime, this is the angle transducer. This is connected to the encoder shaft through a coupling. So for each movement, this angle transducer will generate a milliamps current to the VCU. So that VCU will recognize how much tractive effort or braking effort to be given. That we will see later. Moving on. These are the main functions of the master controller. We have 3 main functions. First one is TB, reference signal generation through this angle transducer. Second one is cam output signals. We have seen that 4 interlock switches that will be given to the SCB or HBB for a reference signal. Then third one is the forward or reverse direction selector. This angle transducer, that what we call the master controller, is connected to the VCU through 2 connectors. We have already seen. One is 13-pin circular connector, the other one is 9-pin sub-D connector. This is the pin assignment for 13-pin circular connector. Here the first one is for common 110 volt DC supply. Second and third for the forward direction switch. Then fourth and fifth for the reverse selection switch. Then 6th, 7th, 8th, 9th, 4 interlocks. 6th is for T, 7th is for B, and 1/3, then 2/3. This is the 13-pin circular connector. This one we have the sub-D connector, 9-pin sub-D connector, 24 volt, then 4 to 20 milliamps current, then the ground signal. Okay, clear? Moving on. For any equipment of the loco, we have a specification. Here the specification for the master controller is CLW ES 3/00331 alternation G. So this, as per this specification, we are getting the master controller. For supplying and manufacturing, this specification to be followed. That link I will share detail of this specification. This is the technical data. Technical data, as per the technical data, drive selection switch, we have 3 positions with the 4 auxiliary switches. There is no angle converter. And for the drive and brake handle, we have 3 positions, mainly 3 positions. 3% means 3 regions, 0 region, tractive effort and braking effort. There 4 contact elements, 4 auxiliary switches will be there, and it will be connected to the angle converter. Then the switch specifications, then angle converter, what type of angle converter, how much supply we are giving to the angle converter, how much current it will be generated. Okay, moving on. This functional test, what are the tests to be carried out in a master controller? Okay, main functional test what we are following in master controller is throttle movement test. In detail we will see later. Throttle movement test, then direction movement test, then mechanical interlock between throttle valve, throttle lever and this throttle. Then angle transfer output, that output current, how much it is generating, that will be checked. First one, in detail, throttle movement test. Here we have the throttle lever, we have seen this position, tractive region, braking region, then 0 position. So, as per the throttle lever, it is giving the supply to the angle, through the angle transmitter to the VCU. So, first position is 0 position. If it is in the 0 position, there will be no output. VCU will recognize there is no tractive or braking effort. So in the position 0, no tractive or no braking effort. All the 4 interlocks, what we have seen in the before slide, there will be no contacts, no output supply from the auxiliary switch. Then the second position, 1/3 position of this T region. This is the T region, up direction. T region, 1/3 position. 1/3 position, 33% of the tractive effort will be given to the converter by the VCU. Then 67% in the position of 2/3. Then in the position of T max, we will get the maximum tractive effort. Likewise, in the braking region, we have 1/3, 2/3, then maximum 100% braking effort. These 3 positions. Okay, clear? This is a schematic diagram of this angle transducer. This throttle lever, we are moving maximum in the tractive region and in the braking region for a 40.5 degree. In the up direction, we can move a movement of 40.5 degree in the tractive region, and also in the braking region again 40.5 degree. So what will happen? That we will see. I already told this throttle lever is connected to the encoder shaft through this spur gear, where the spur gear ratio is 1:3. So when the spur gear is moving, here the interlocks 1, 2, 3, 4. This is the first interlock which will recognize the tractive region. That means we are moving the throttle lever to the traction region. For a 15 degree moment, this interlock will be closed. Meantime, here the 15 degree, for this 15 degree moment, VC will recognize either tractive or braking effort has been taken place. But this is also connected to the angle transducer. Angle transducer will develop a current of 4 milliamps. Normally in the 0 position, we have 2 milliamps output from the angle transducer. That will be supplied to the VCU. And also here in the 0 position, there is no interlock will be closed. So both will be compared by the VCU. If we are working in the cab 1, FLG1 will be compared. If you are working in the cab 2, FLG2 will be compared. So in the 0 position, there will be 2 milliamps current output from the angle transducer. When we are moving a 15 degree of the encoder shaft, the output will be 4 milliamps. That time, this first interlock will be closed. So both will be compared and VC will recognize we are moving in the tractive region. So first interlock will be closed and the output will be 4 milliamps. Otherwise, if you are moving in the braking region and for a 15 degree moment, the second interlock that will be closed, then also the output will be 4 milliamps. So that will recognize, both will compare and it will recognize we are in the braking region. VC will recognize this logo is in the braking region. So further, if you are moving again the throttle in the up direction, third interlock will be closed. So for a 31.5 degree moment, this will be increased, the current will be increased and it will go up to the 20 milliamps. So that time VC will recognize maximum tractive effort will be given to the loco. So maximum tractive effort giving time, all the interlocks will be in closed condition. No, sorry, not all three interlocks. The second one is for tractive region or braking region. For recognize that only. For first interlock will be closed means tractive region. Second interlock closed means braking region. And the third and fourth one for 1/3, 2/3. So all the three are closed means maximum effort will be given to the locomotive. Moving on, this is a circuit. Here already we are told this is the reverser or direction selector switch. We have forward direction for reverse direction. Four auxiliary switches are there. One is for redundancy, so which is connected to STB, STB1, then STB1, STB2 for the reverse. Here we have the cam switches, encoder shaft connected with four auxiliary switches. One is for tractive region, another one is for braking region, the third one is for 1/3 position, fourth one is for 2/3 position. Okay. Then the angle transducer. This is the angle transducer output which is connected to the FLG1. So here both the input will be collected and will be compared, which is in the forward region, which is in the tractive region, how much of tractive effort to be given, that will be compared by the VCU and will be given to the loco. So next functional test we are doing is direction movement test. So direction movement already we are told this is the direction selector switch, three position we have, reverse, zero and forward. So we have to check the direction switch is working normally, smoothly we can able to rotate. That we will be checked. Then position F means forward, position 0 means neutral, position R means reverse. Okay, moving on. And also, once we have selected either one direction, either forward or reverse, then we can move the throttle in the up or down direction. That means tractive effort or braking effort we can give. But until we have reached this direction selector to this zero position, we can't able to change the zero. Sorry. Once we have selected the direction selector to switch to the forward direction. Once we have selected, okay. Then we are taking tractive effort. Then if you want to change the direction, we can't able to change directly to the reverse direction. First we have to reach the zero position of the throttle, then only we can change the direction. Okay, that we'll see later. Here we can see, here we have a lever which is connected to the drum of the throttle lever. So here one slot is there. Once if the throttle lever is in the zero position, the direction selector switch will be engaged with the slot. If you are moving the direction selector switch to either direction, forward or reverse, it will be disengaged with the slot. So we are moving the throttle valve either in the forward direction or in the reverse direction. So this slot will be dislocated. So unless we are moving to the zero position of the throttle lever, we can't able to re-engage it. So sudden change of direction we can't able to do. So that we will check in functional test. We will check whether it is working properly. That function we are checking. Then the other test is angle transfer output test. We have a test kit which is connected to the angle transducer and with the 13-pin circular pin and 9-pin sub-D pin. Both are connected to the test kit. There we are checking. Here we can see the direction selector switch output. So two switches, two indicators for the forward direction, two indicators for the reverse direction. Here we can see four LEDs. One is for the tractive region, one is for the braking region, one is for 1/3, one is for 2/3 position identification. Then here we can see the current output from the angle transducer. Here maximum we will get a 4 to 20 milliamps. Here some tolerance will be there, that will be seen later. This is the tolerance in the zero position, forward standard values. These are the tabular column. That we will check with the test kit, which is following or not. Okay, clear? Then moving on, any doubts? Then moving on, the fault code, main fault codes we are having with the angle transducer is F1703P1 and F1803P1. which means if you are working in the cab 1, we will get a fault code of F1703P1. And if you are working in the cab 2, the second fault code will get. This is the fault code of F1803P1. What it means? Fault in angle transmitter. Angle transmitter is failed. How it will happen? That will say, if once this message is displayed on the screen, further also we can run the logo by this operation, failure mode operation. Once angle transmitter is failed, we can able to run the logo by this operation, failure mode operation. First of all, we will see how this failure will happen. Already we have seen this angle transmitter and auxiliary switch output from the encoder shaft. Both are comparing with the VCU. So when the difference between these two inputs are more than 25%, VCU will recognize angle transmitter is failed. So that time this message will be displayed. Okay. So this current value. Here I have shown some reference values. This value will be compared each and every time by the VCU. When and where this value is differencing with the internal the auxiliary switch output, that time VCU will recognize angle transmitter is failed. That difference will be more than 25% of that maximum value. Okay, that time this message will be displayed on the screen. Further, how to work? So what will LP will do at the time of angle transmitter failed message is displayed on DDU. So for operation that failure mode operation, here in the SB1 panel, one rotary switch is there, failure mode operation switch 152, which will normally in the 0 position. And if it is failed, angle transmitter is failed, we have to work in failure mode operation. We have to rotate this switch to the 1 position. Okay, that time this will be in, normally it will be in the 0 position, then to the 1 position, this continuity will be not be there, then VC will recognize angle transmitter is failed, angle transmitter output need not to consider. So after that, we can able to take the values of encoder shaft auxiliary switch output. That only will be considered by the once the angle transmitter output is failed means that we are switching the 152 switch to 1 position, then this output will not be considered. This output only will be considered by the VCU. Okay, that's all. Then case study. We have displayed our 2 case studies. One is logo number 37387. Here, as I all told, this is angle transmitter failed logo. Here, what the issue happened is, in this logo, angle transmitter failed message was displayed. After that, LP tried to work in failure mode operation. But after that also, logo was not able to run because here the failure happened in the auxiliary switch, first interlock, that is for recognizing the T region. That was broken and that continuity was not available. So loco will not work because once angle transducer failed, we can work in failure mode operation. But here the secondary plan B is failed, so loco was not able to run. So after that, before this failure, we don't have any action plan. One this angle transmitter is POH must change item. We will check and function the functions of the angle transmitter. But after this failure, we have taken an action plan of changing this auxiliary switches in every overhauling as a must change item. So after that, we are following that practice. Already on railway headquarters on a letter also issued. Then second one, this is case study 30784. In this logo, AL make, we have different makes of this angle transmitter. Here the failure happened in AL make angle transmitter. There we have encoder shaft and angle transmitter. Both are coupled with some coupling. Here in this type of this make angle transmitter, the coupling will be with some type of backlight material. it is cut and that connection was missed. So angle transmitter output was not there, but loco was able to run in failure mode operation. So after this failure, we had checked all the AL make angle transmitter and we had identified almost after this 3 more cases we had identified total 7 numbers of this issue we had identified. But in other make angle transmitter, this coupling is different. Metallic coupling was there. So we had addressed to the company. They are changed. This is the type of coupling failed in loco. After that, they had changed this design. Okay. This is the FRPCPY of angle transmitter for the last year. So here the main culprit is this AL maker because of that coupling issue. Different failures we have given in this starter. Okay. Any doubts? Thank you.